So in this section, we're going to be graphing rational equations. So remember, whenever you're graphing, you can use Desmos. So always have Desmos open the graphing part. And it's really good to just graph these and make sure your numbers match up. Okay, so just some vocabulary. We're going to talk a lot about domain. That's all possible x values of an equation. And then interval notation is what we use when we write what the domain is. And you write a smallest value, comma, largest value. And I didn't put this in here, but I want you to think of like a number line, like when we had a middle school. If we had an open dot, that means not included. Okay, so when something is not included, using interval notation, we use parentheses. And then sometimes on the number line, we would have a closed dot. And that means the value is included. That means it exists. And when that happens in interval notation, we use brackets. So in this section, we're only using parentheses, but we might see brackets later on. Okay, we're going to look at things called asymptotes. That's a value that the graph approaches but never reaches. So an asymptote, that's a value that's not included. And then I hope intercepts or reviews, we have x-intercepts where we cross the x-axis, a y-intercept where we cross the y-axis. Okay, and we write those as points. So an x-intercept is an x value when y is 0. A y-intercept is a y value when x is 0. So let's just go over an example really quick. I have 4x plus 1 divided by 2x plus 1. This is a rational function because I have a polynomial on the numerator and the denominator. And here's a picture of the graph for us. So your questions today, they're going to ask about domain and asymptotes. So when you look at a graph, a rational function graph, you can actually see the asymptote. It's right here where the curves go up and down really quick. There's also one here. We call this the vertical and the horizontal. But section 2 talks about horizontal. Today we're just going to focus, or this section, we're just going to focus on the vertical because we're talking about domain. Okay, so when we have domain, to find the domain of a rational function, set the denominator equal to 0, then solve for x. So domain, I'm going to take the denominator, 2x plus 1, set it equal to 0, and now we solve. So minus 1, minus 1. 2x equals negative 1. Divide by 2 on both sides, x equals negative 1/2. So we just found the asymptote right here. This line right here is x equals negative 1/2. And that is the value when the denominator is 0. So what happens when a denominator is 0? It's bad. This cannot happen. That's why we get the asymptote, because we cannot have x equals negative 1/2 on the denominator, because we cannot divide by 0. So that's where the asymptote comes from. So when we're looking at domain, we just found the value that x cannot equal. So for the domain, x cannot equal negative 1/2. Okay, so let's write that in interval notation. And I'm going to write it over here. So look at our graph. It goes forever and ever and ever and we're looking at the x-axis, domain is x, all the way to negative infinity. And the graph continues, and it gets really, really, really close to x equals negative 1/2, but it never reaches it. It can't divide by 0. So our domain goes from negative infinity, and then we're going to write it goes to negative 1/2, but we're not going to include it. That's why we do parentheses. Okay, if you need to, think of a number line where negative 1/2 would be an open dot. It's not included, but all of this is included, all of this is included. All the way from negative infinity all the way to positive infinity with a break at negative 1/2. So we have one interval here and we have a second interval. So when we have two intervals, we write a union. That means that there's more than one interval. So then we're going to pick up again at negative 1/2, but we're not including it. So there's parentheses at both. So right here, we're going to pick up again, and our graph's going to go forever and ever and ever and ever to positive infinity. So this is called interval notation. This is an interval. This tells us where the graph is on the x-axis. Okay, that's the domain. You're also going to be asked to find intercepts. So you can use algebra or you can graph it. So if I put this in Desmos, 4x plus 1, and then I'm going to highlight this and divide by everything, 2x plus 1. Here's the graph. You can find the intercepts on the graph, but you might need this as a fraction. Okay, so 0, 1, negative 1/4, 0. I'm going to do it algebraically because there are some problems where you have to. Okay, so remember the x-intercept is where y equals 0. So remember, all of our functions are y equals. We just don't always see that. So I'm going to put the whole function equal to 0. And now we have to solve, but it's not that bad. We're going to get rid of the fraction by multiplying by the denominator on both sides. So they cancel over here. 0 times anything is just 0. So really, the denominator just goes away. And now we're going to keep solving. So -1, -1. Divide by 4, divide by 4. So x equals negative 1/4, which we saw in Desmos. This x-intercept is negative 1/4 when y equals 0. I'd write that as a point. Okay, and then the y-intercept, that's when x equals 0. So I'm going to take this function, and everywhere there's an x, I'm going to put 0. And we end up with 0 plus 1, 0 plus 1, 1 over 1, or just 1. So the y value, when x is 0, y is 1.